Hi, welcome back to the breadboard. In this video we are going to assemble the gantry for my Voron 2.4 350mm by 350mm. We've already assembled the frame and put the linear rails in the Z-axis. In this one we're going to be adding linear rails to the Y component, MGN 12 linear rail to the X component, and putting it all together, save wiring or save running the GT2 6mm belts until another video, but we'll get it all ready to hang into the 3D printer. Now I've already assembled two of the two Y junction pieces. They're nothing complicated. You can see here that the assembly basically consists of two pieces which were 3D printed in ABS, motor with pulley, and some of the flanged bearings. Now the manual is very clear about how to put this together. The left and right side are pretty much identical with a little bit of an exception here. You can see that on this particular bearing it's on the top of the rail mount, and on this one it's on the bottom. They actually go up this way. The other part is this one has two heat set inserts for additional add-ons later on. And I've already shown you how to put heat set inserts in anyway. And then they just screw together with M5 bolts. Now this is normally specified as a round head or button head. I don't have any of those, so I've just put in these standard sockets for now. They're cosmetic for the round heads. They're not going to interfere with anything. So one is for each side of the frame, and the frame consists of three pieces for the outer frame, which is where the belts are going to run and everything else, and then another extrusion for the X rail. Now the size of these for a 350 by 350 is the rear component is 340 mil, plus the width of these, of course, will make it up to the full width. The left and right pieces are 450 each, and the X gantry is 430, plus of course these two, which makes 450. The components you see here, which I've assembled, again these are very simple things, so I didn't record doing it. These are for the belt adjustment at the front of each of these gantry pieces. We'll be putting those in later. These components here are the end mounts for the X gantry. So the MGN 12 will mount on here, and then these, once they're assembled with the pulleys and things which I have here, will mount on the ends of here and then screw onto the MGN 9 rails that we have for each side. Now the one thing I want to point out with this is my rails are not Mitsumi rails, so they have a little notch. I'll put an insert in to show you in the end here that causes them to be maybe 0.8 of a millimeter either side to be able to connect with the edge of these rails. And considering the edge of these rails have a tiny chamfer too, it's barely half a millimeter. Not ideal, but usable. So what I did to compensate for that is I designed and 3D printed a whole bunch of, and they have a half a millimeter by half a millimeter little tab sticking out one end, which will fit into that half millimeter notch pretty much perfectly, and they're just the right height to sit at flush with the top of the rail. Now I will provide the step file on my GitHub repository or something if anybody else wants to use it. I designed it in Fusion 360. It's not complicated, but seeing as every manufacturer's rails could potentially be marginally different, I'm not going to try and claim that it fits all different rails. You'll have to tweak it for your own. Okay, but it's pretty easy to do. Anyway, so what the idea is, as you can see with this rail, I just put these in. They're a tight fit, and then I just slide the M5 barrel nuts in between them, and then you can align them up. And what that does is it prevents the MGN 9 from dropping in and twisting itself when you're trying to assemble it all. It's designed so that there's going to be a minor bit of compression. I only used 40% infill, but they will support the rails. I've already done the same thing for my Z-axis components. The x-axis one I'll do in a minute. I'm just going to move that out of the way, and we'll get started with the y-axis U-shaped components. In the manual, we pretty much left off here. I added the skirts around the bottom as well, just to get them out of the way, basically. But we've got our idlers in, we've got our linear rails in. Mine are longer than the stock ones because I did a 500 high instead of a 320 or 350 high. My whole design is taller. Same X and Y though. I haven't got the bed screwed on. I'm going to do that in a separate video. I'm leaving it off right now just to keep the frame lighter while we're doing these other parts. So the next stage, aside from the bed, and that also comes under electrical as well, which is why I'm delaying it, is to skip past the bed, is here. So AB drives and idlers. So I've assembled this bit already, and this and these two pieces. They're very, very simple, but let's just quickly scroll down and see what's involved. 4 pieces, so 2 heat set inserts, we've covered that, couple of M5 nuts on the bottom of the idler adjusters. Assembly of these flange bearings is pretty much the same everywhere. Whenever one is used, you have a washer, bearing facing each other so that you can acts as a constraint for the M6 belt, and then another washer on the top. These are precision 1mm thick washers. So you don't want to get the kind that are badly stamped with burrs on them and stuff like that. When you assemble it, you've got to just make sure you pay attention to the orientation. These parts have a little bulge on one side, which helps you to identify where they go. The washer it could be pretty much any washer as long as it fits M3. The idea is to provide a bigger area of purchase against the plastic, because you're going to use this for tensioning the belts and they'll get quite tight, so you don't want the head of the bolt compressing into the plastic. Once you've done one side, you do a quick review, make sure you've got everything correct. This is a very good view here to be able to check against, and then you assemble the other side, and it's basically the same process, just basically mirrored. Quick view to make sure you've got it all assembled correctly. And with that, you will end up with this side. There's our idler in the middle. Okay. Our adjustment screw with a washer. And our M5 bolt right through into the nut. Don't tighten this one up too much, because you do need this to be able to slide. Okay. And same thing for the other side. When you're assembling the motor mount end parts of the gantry, the pulleys, very similar to the Z motors, have a generic template for the adjustment that you can print off. You can print it off on PLA, whatever you like, doesn't matter. And it's got marked Z, B, and A. This one's the A pulley. Anyway, you use it this way against the motor. Obviously you can't see it here, but when you sit it on top of the motor and you push it in, it should just go between the two flanges of the pulley, and that sets your height. When you do the B side, you use the other side of the pulley, and it's marked A and B, and you do the same thing. And you can see here the pulley is upside down compared to this one. So one's up, the one's down. That's because the belts basically run on top of each other without touching. So you need to make sure that that is accurate. Now, when you're assembling these A drive and B drive components, you need to be careful. You assemble them, as you can see here. So you got washer, flange bearing, washer, washer, flange bearing, washer, etc. Like I said, they're all pretty much the same assembly technique. One is to mirror the other, and the one has the bearings up high here. One has this bearing down low. But once you've assembled them, you're actually screwing these M5 bolts into plastic. There are no heat set inserts for them, so don't over tighten them. Here's what I was saying about adjusting the pulleys on the stepper motors. Very straightforward, very easy. When you mount the stepper motors, you want to mount them such that when they are mounted onto the rail, then you want to have the power cables coming onto the inside. So each of these is going to mount like this. The motors will be toward the back, and the cables for the motors come on the inside, so they can run along the extrusion if you need to. We only mount the motors with 3 M3x30 socket head screws. They go right through the prints into the motor. Again, you need them snug, but they don't need to be massively tight. Just maybe a little bit of Loctite if you want on the ends of just on the tips of the screws. And then you need to check your work. So as I said, one of them you're going to have 2 bearings stacked and then 1 bearing on the high side. When you do the B drive right here, we go through there, and then when you do the check, again, do not over tighten because you're going into plastic. When you do the check at the end, whereas here you see this one is 2 on the outside, 1 low on the inside, so they are different positions for one of the pulleys. So once that's done, now we need to assemble this. All right, we've got this piece done, we've got this piece done, we've assembled this, but we haven't put any of it together. That's where we're starting now. Okay, so this is what we're going to build. What I have in front of me now is the A drive and the B drive. One of the biggest distinctions for the A drive is this notch here. If I go back to the screen, you can see there's a notch in the plastic of this one. There is no notch in this one. It's also a different shape. So very clear to distinguish which one's which. The right hand side one is also the one that has the 2 heat set inserts on it. We need 1, 2, 3, 4, 5, 6, 7, 8 M5 T-nuts, and we need the extrusion, which we've already got. So let me just grab those and I'll be right back. I'll also grab the screws that we need, which will be 1, 2, 3, 4, 5, 6, 7, 8 M5x10 button head screws. Now I've mentioned this before, but I'll say it again, it's in your own interest to try and keep all of your screws and belts and pulleys and everything else all nicely organized. So that's what I have here. So I've got all my M3 screws and my M5. So what I need is my M5x10 button heads, which is these ones. So we'll pull those out. It's more than I need. I need M5 roll-in T-nuts, not the M3s but the M5s. So I need 8 of those. 5, 6, 7, 8. I'll leave the rest out because we may well need those later as well. And I think that's it for the moment. Alright, so we have our 2 components, assembly, sorry. We have our extrusion, and we have our M5 inserts. Let's go back to the instructions, see what it tells us to do. Okay, so first thing to do is to put in the M5 T-nuts. Now you can roll these in or you can just slide them in. Doesn't really matter, but the one thing to note is that the holes are toward the outside on each end. Holes toward the outside. They can just slide in, it's just easily. Now you can also just put these in by rolling them in. If you put them in like that, you'd have to use something to just roll them and get them to spring into place. That's not quite right there. You can see sometimes it's not quite as... There we go. Now it's in. Alright, now you need them near the end, according to the diagram. But I mean, it's about how you mount them. Same as this end, we want the holes toward the outside. When they're near the end, it's just as easy to do this. Now we need 2 on the opposite side as well. And I'm going to be using these M5x10s. So the next stage, according to the diagram, is, scroll down here, we've got the 2 on the top, 2 on the bottom on each side. Is to put the M5x10 button heads in. So we're going to put the right hand side one in, and then the left hand side, and we're going to screw them down. Now there are notches in the, see if I can show you, there are some ridges which go on the inside of the extrusions. Now if your extrusion is not the exact width of these, there may be a little bit of play, but once you tighten it down it should be fine, and we will be adjusting all of this before we're finished. Now I just measured mine, and the track that's going to fit in, my T-slot on the extrusions is 6.2 millimeters, and the raised portion on the plastic 3D print is 6.2. So there's like a half a millimeter of free play. That should be fine. If you've got official Misumis, it's probably going to be a much better fit, obviously. So picture says stick them in and screw down the screws. And as you can see there, the screws are pretty well lining up, which is nice, but you can see why you need to have them fairly accurate. Alright, so let's get some button head screws and screw them up. I'm going to put all the screws in and just nip them up gently. I'm not going to, and then I'll just fast forward this next bit because you don't need to watch me screwing screws in, do you? Do want to make sure you push them all the way in. They will slide, but you want it pushed all the way in. They're designed, if you've cut the extrusions to the right length or they've come pre-cut, they are designed to bottom out in here. Okay, so now we'll do the other side. Same process. Get the screws in first and then worry about pushing it all the way in. Alright, so that's that step done. Let's go back to the screen. So we put that one in, screwed it down just gently, put that one in, same process. So if we look at it from the end on, you should see that the right hand side one is low, right here, so you can see pulley teeth low, pulley teeth high, and if I look at it from, yeah, so that's what they've done, they've just flipped it around. So next thing is we're going to put the rails onto our extrusions for the Y carriage. We'll break this video off here because it's getting a little long, and we'll continue at the gantry part 2. So see you there. Bye.